closer look at algorithms, we see that it is impossible to write a program code for the computer to interpret without using algorithms in some form. It forms part of the building blocks of a computer program. In its simplest form, an algorithm is a series of steps that must be performed to accomplish a particular objective. An algorithm must consider three factors: input, process, and output. The input we provide to an algorithm is processed with the help of a procedure, and the algorithm outputs the results. Some points to take off about algorithms. An algorithm is a sequence of steps used to accomplish a particular task. It can have zero or more output. It must have at least one output. It should be efficient both in terms of memory and time. It should be finite. Every statement should be unambiguous. There are three main ways of writing an algorithm. You've got the English-like algorithm, you've got the pseudocode, and then you've got the flowchart. Now, the English-like algorithm uses the strengths of the English language to communicate the processes to be accomplished in a computer program. We'll be looking at the linear search algorithm and be taking a step-by-step approach to breaking down the steps required to implement a linear search. Now, basically, we've got step 1, compare item with the first element of the array, A. Step 2, if the two are the same, then print the position of the element and exit. Else, repeat the above process with the rest of the elements. Then step 4, if the item is not found in any position, then print not found and exit. The flowchart algorithm uses a pictorial chart diagram to communicate the processes to be accomplished in a computer program. We'll also be looking at the linear search algorithm and see how we can represent the algorithm in a flowchart diagram. The pseudocode algorithm is like writing a code, but writing it in a short form in such a way that only a coder or programmer can understand the algorithm. We'll also be looking at the linear search algorithm and see how we can represent the algorithm in a pseudocode. We'll be looking at how to apply some algorithms to try to solve some problems from Leet Code. As you can see, we'll need to browse to the Leet Code website and explore all the different challenges that the computer problems that we'll need to solve on the Leet Code website. Okay, so now let us begin. All right, thank you for joining today's session. Today we're going to be looking at a couple of programming challenges from Leet Code. And just to have a look, we're going to start with the reverse integer problem, and we're going to looking at the background. Given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, so here's your range, then return 0. Assume the environment does not allow you to store 64-bit integers. So that's our assumption. And then here we've got in our algorithm the algorithm we're supposed to use, we've got the input, which is x, is equals to 1, 2, 3. The output will be 3, 2, 1. We do the same thing with a signed integer, which will be minus 1, 2, 3, and then our output should be minus 3, 2, 1. So this is essentially what we need to do to get our program going. So the remaining examples are also given the same thing. Here we have x is equals to 120, and then we get 21, and then x is equals to 0 would give you 0. So let us now start with our program. The first thing I'll ask us to do is to set a variable of reverse string to null. We can actually make it an empty string like that, but I prefer null. So we're going to use null. And then the next one is to say that signed is set to false. This time we want to check that if the integer is less than 0, we can make it a signed integer. So basically we're going to set the signed, which is a boolean, to true. Okay, and then the next bit is to create our string. We're going to use a typecasting. So we're going to typecast and cast our string of x to a string variable value, but then what if we have a negative value? So we can use the built-in PHP absolute function to convert it from from a negative to a positive value. So we'll always receive a positive value. And then the next one is to say that the approach, we're going to use approach 1. So there's approach 1 will be, we're going to manually reverse the string. And then by so doing, we're going to say for, and here we've got $I is equals to, here we're going to say $string dot length -1, and then we can say $I greater than equals to 0, and then we're going to say $I minus, okay, and then here we're going to say reverse string is equals to, once again we can say reverse string is equal, and then we say we use a concatenation operator, and we say string $I. But a good way to actually improve this, we're going to use our combination operator. So we're going to say dot is equals to, as opposed to that is the same thing as this basically. So just by saying dot operation, that will give us the same thing. And then we're going to then convert our reversed integer back. So we're going to typecast from integer of the reversed string. So now that we have our reversed string, we're going to convert that back to so just to explain this algorithm here, we're starting from the very end of the string, and then we are going all the way back to the beginning of the string basically, but we're going in the reverse order basically. And you can see we starting at a large number and we're going all the way down to a small number basically, and that's why we're using the decrementer to decrement the string basically. Okay, so then now the next thing is we're going to say if $signed, and then this time around we want to if this integer is signed, that we already picked up from the beginning, that is signed, actually we don't need to put our if statement there. I think there might have been, we just need to structure this a little better. Sorry, I think our code editor there will reject our code if we don't do it this way. And then we need to have another if statement at the end there. Okay, so that ends the function, and then this one ends this if statement here. And in this if statement we're going to say reverse is equals to minus reverse, negative reverse, and this will ensure that if it's a negative value we should return it back as a positive value. And then the next part here is to check that the smallest is equals to -2 to the power of 31. We're using the power operator, which is a double asterisk there. So that is the smallest range. This is based on the constraints that we have mentioned here at the bottom. And then we're going to go to the largest. So the largest is equals to 2 to the power of 31, then -1. Okay, so that's essentially what we need to do. And then now we do our comparison. And in our comparison, we're going to check that revision smallest is within the range basically. So then we say the range is greater than smallest, or revision is less than largest. So we say largest, and then that should solve our constraint. And then we can then say return revision. Okay, so if that doesn't work, we're gonna say return 0. So if it doesn't fall within the range, we're gonna just return 0. Also take note that I am not using an else statement in any of this program code that I've written. The reason is that it makes it a lot easier, it's more readable. Your code becomes easy to read when you do not have as many if else statements. I'll go into detail of this in the future sessions, but for now let's just take it as this, and we're just gonna look at the code as simple as it is right now. So now let's try to run the code and see what happens. Okay, so we have accepted the results, and then from this point here, we're going to then take, it took a while for it to run the code there. That's probably because we are using a reverse string option. It took a long time to do that because we ran a loop. An alternate approach is to use, what do you call it? We're going to use a built-in function, a built-in PHP function to reverse the string. Okay, so then with the built-in function, we're going to say the reverse string is equals to string reverse. That's a function, and then we're just gonna say string. Okay, and then now let's run this code once again. Oh, that was quick. So you can see that the time complexity, the time and space complexity was pretty large for the last one. So now it's been reduced just by using that function there. And then we can then submit our code. And let's see if it does accept our. And there we go. It did accept the code, and we have solved the problem. So, well, once again, thank you for joining this session. I enjoy having to spend some time with you so we can just solve the problems. If you have any comments down below, please drop them below, and so I can answer to your queries, and I'll be able to assist you with anything that you would like to help with. So have a good day. Thank you. So please remember to subscribe to my channel, and so you can get the latest updates whenever I upload videos. You can actually check out and see what we have in stock.